Here's a nonlinear first order differential equation, and it was actually quite difficult to come up with something that was simple-ish, that could be solved, that was nonlinear, that didn't have anything weird go on. So right, this isn't the simplest I could have picked, but it also doesn't have weird behavior, and it works out somewhat well, and I can solve it. So it's you don't always get all those. So it's a little hard to find this one. So y prime is equal to sine of y. The only thing we can do is to figure out the interval validity is to solve this equation. Well, so I'm going to kind of go through the steps here pretty quick. So this turns out to be a separable equation. So this is dy over dx equals sine of y. All right, so you can write that as dy over sine y equals dx. You can integrate both sides. This side turns out to be the natural log of the absolute value of tangent of y over 2. And then this other side ends up being x plus c. If you go through, do all the steps to solve that, you exponentiate, you use arctan, all that fun stuff, you end up with y of x equals 2 times arc tangent of a constant times e to the x. There's a little more to it though. So when you're doing the arctangent, tangent is repeating, so it gets the same value every time you add an integer multiple of pi. So it actually turns out that you need n pi on here. And you end up getting the same behavior, because right, if I add n pi into the sine, then it doesn't do anything. And then the y prime will stay the same. And actually, I think it was, 2 n pi in here, but then the 2 in there cancels it out. So what this ends up looking like is, let's see if I can get this. All right, x, y. You have at different values of pi, so I'm just going to call that one pi, and this one's going to be, what was that, 4? So that's 4. Negative pi. And I should say here, other options, well, if the c is 0, I think it works out. So this is 0 pi, right? And then up here we'd have 2 pi and negative 2 pi. Solutions do end up doing this. Just over and over again. And here, they end up doing the same thing. They go away. And these ones will end up attracting, so I'll just put down 1, 2, 3, 4. This one should be negative 2 pi. And then this one up here will be positive 2 pi. And it kind of repeats the behavior over and over again. So this one will attract, this one will repel, and over again. So this one actually doesn't have any problems. There are no discontinuities in here. We've got this n pi, so if you start at a higher value of y naught, you're going to end up having a different n. And I should say here, n is an integer. And so this one actually works out nicely, despite being a nonlinear differential equation, right? Sine of y is pretty nonlinear. So that's the end of this one. It's a little annoying to solve and to figure out where this n pi comes in, but it does work out. And the next one is going to have an interesting twist on the difference between interval validity and the existence and uniqueness theorem.